This meeting is being recorded.
Problem 5 from Chapter 10 asks us to identify what is the weakest CH bond in each of these following compounds. So in order to do that, we should consider or imagine which protons being removed, which hydrogens being removed would result in the most stable radical. So we need to factor in homolytic cleavage of a CH bond. In this instance here, we have, hidden hydrogens here, here, we have one here, one here. We have 3 on each of these methyl groups, 3 over here. We also have a hydrogen right here. So if we were to remove that hydrogen that is circled, we would result with an allylic radical, and this could be resonance stabilized. So that's the only site of hydrogen abstraction that would result in a resonance stabilized radical. So therefore, that's the hydrogen, and the weakest CH bond would be between the carbon and the hydrogen that's circled. If we look at compound B, again, we want to imagine what radicals could result by cleaving a CH bond homolytically. So let's draw in our hydrogens here. So if we were to remove one of these hydrogens indicated down here, that would result in a secondary radical. And that could generate a resonance stabilized radical. Also, we could remove this proton up here, and that would generate a tertiary radical. So either of these sites would result in radicals that could be resonance stabilized, but the tertiary allylic radical, so if we were to draw this out here, we have a radical site there. This tertiary allylic radical would be even more stable, and therefore this top CH bond would be our weakest. So where the hydrogen was, where that radical has resulted. When we look at compound C here, we can imagine, again, what type of radicals could result that could be resonance stabilized. So if we remove a hydrogen from the site here, we could generate a resonance stabilized radical through homolytic bond cleavage again. And therefore, this carbon-hydrogen bond here, one of these 3, would be the weakest within our compound. And then last but not least, let's look at the possible radicals that could result in compound D. So we have 3 hydrogens over here that could result in an allylic radical that could be resonance stabilized, or we could remove a proton from here, and that would be an allylic radical as well. So let's take a look at what would happen if we did either of these sites. So if we removed one from over here, this would result in a primary allylic radical, versus if we removed the one over here, that would result in a tertiary allylic radical. So this bond here, this CH bond, would therefore be our weakest because the resultant tertiary allylic radical is more stabilized than the primary.